This is experiment number 7. First is means implementation. First, we'll install all the necessary modules like fuzzy, Siemens, pandas, numpy, matplotlib, and scikit-learn. After the it installed version, we'll go to the first question, which is importing all the necessary data, like using the dataset. The dataset which I'm using here is while fcm.csv, and sending a PDF. And after successfully loading the dataset, this is the shape of that particular dataset. And then this is pre-processing. Where I'm using the missing value imputation with new. So df is equal to df dot fill and name of df dot mean function. That is, it fills the missing values and non-values with the mean of that particular column. And I'm taking the feature extraction as features equal to df dot columns. And the next is standardization. The standardization and using standard scalar and x is standardized to x scaled. The DF dataset is standardized to x scale. And next is initialization. So we are taking fuzziness index ms2 and maximum number of iterations max iter is equal to 150. And this is the initialization. And into the next question, it's visualizing the input feature distribution. So after all the visualization would look like this with alcohol on x-axis and malic acid on y-axis. So this is the standardized result and there's a scatter plot. Next is the performing CM clustering with different number of clusters in a loop. So this will perform the same clustering with clusters 2 to 5 and use the FCM function from the SC names library. It will then predict the label and compute the cell house score for each cluster number. And the cell house score is calculated using the function cell house underscore score, and labels are calculated using FCM dot predict. And FCM is nothing but FCM as capital letter FCM of clusters is equal to n clusters. And the cluster range is already defined as 2 to 5. And max item is 150 and m as the function is already visualized as 2. So that's it. I'm going to the next question. It's plotting the cell house score curve. It's a cell house score curve with cell house score on y-axis and the number of clusters on the x-axis. So it's increasing initially and then it's declining when coming towards 5. The number of clusters is equal to 5. Now evaluating the cluster performances. Here we are using the for each cluster we are using cell house score, then PC and PEC. That is the partition coefficient and partition entropy coefficient. And the result is as shown here in the report. So next question is to choose a model with optimal number of clusters. So we are picking a model which has the higher cell house score, and out of all these four, the one with the higher cell house score is the one with cluster number is equal to 3. So the yeah, using cluster is okay. So we got the number of clusters based on the highest cell house score is 3. Going to the next question, it's utilizing the clusters. So this one shows a scatter plot to visualize the clusters with optimal number of clusters, assigning different colors to each cluster for better distinction. So this will show the output with the cross mark as Android, and there are like 3 clusters here. Display the clusters Android. So in order to display the clusters Android, we are using an optimal centroids as the input parameter here, and then print the centroid DF to get the optimized optimal centroids of the data distribution. Next is visualizing the clusters in Tableau. So first of all, we need to export the data to a new CSV file for Tableau visualization, and after that, upload that file in Tableau, and you can put various the elements here in columns and in rows to get your desired output. So this is a scatter plot with the alcohol on the x-axis and uh, uh, malic acid on the y-axis. So this shows the scatter plot. Thank you. Thank you.